Okay, number 15, I might be posting these out of order, FYI. But number 15, find the Taylor series about 0 for each of the following functions. Give the expansion up to and including terms involving x cubed. Okay, there's a reason why the professor said that second sentence. We'll see why in a bit. Okay, so cosine x. How do we find the Taylor series of that? You should have this one memorized, actually. So you don't want to waste time deriving the Taylor series for cosine x. Have this one memorized. The summation notation is like this, or if you remember the expanded form, it's just the even powers, okay? With the even factorial on the bottom, and then you alternate signs. So up to the x cubed term, it'll just be 1 minus x squared over 2 factorial. I don't know why I copy pasted it twice, but that's it, because the next term would be x to the fourth over 4 factorial. We're only asked to expand up to x cubed. Okay, so those are we only need the first two terms. Okay. Part B, 1 over 1 plus x. So you should have memorized the Taylor series of 1 over 1 minus x, which is summation n goes from 0 to infinity, x to n. Okay, so to get from here to here, just replace x with minus x. That's what I did here, which we can write as minus 1 to n, x to n. And now we expand term by term. So this is why going from the summation notation might be helpful instead of directly going from the expanded notation. In this case, it doesn't quite matter because it's only a few steps, but sometimes it's just easier to work in a compact, concise notation, the summation notation, but then sometimes it just works better to work in expanded notation. So it just really depends on the problem. Right? So in this case, I typically prefer to work within the summation notation. I like it when it's concise. Okay, so I expand up to the x cubed term, it looks something like this. Okay. It's pretty easy so far. Now it's asked us to find cosine x of 1 plus x, the Taylor series for this. Not a coincidence that it's a times b, right? Cosine x times 1 over 1 plus x. So we got to use the answers from part A and part B to our advantage, okay? We can just multiply the two power series, right? Cosine x times 1 over 1 plus x is this, so we can multiply the power series representations. Okay, so that's why the professor said, give the expansion up to and including x cubed, because this will help us out for part C here. Okay. So cosine x is 1 minus x squared over 2 factorial plus so on and so forth. And then 1 over 1 plus x was 1 minus x plus x squared minus x cubed plus dot, dot, dot. Okay. So we got to distribute now. So we distribute this 1 to these four terms. You have 1 minus x plus x squared minus x cubed. If we distribute this minus x squared over 2 factorial to all these terms, we only keep up to the cube term, by the way. So we would get minus x squared over 2 plus x cubed over 2. And then the next term would be x to the fourth. We can throw that out because we only asked to keep to x cubed. And then it'll be x to the fifth. We throw that out as well. Or we put it in the dot, dot, dots, technically. Okay? And that's why we kept up to the x cubed term. Because the next term, and again, for the cosine x expansion would be x to the fourth over 4 factorial. You start distributing, all of them are above x cubed, right? The degree. So they will just get lumped to dot, dot, dot. So now we just combine like terms from here. You get 1 minus x plus x squared over 2 minus x cubed over 3, x cubed over 2 plus so on, so forth. Okay, so we just had to do some algebra. And we had to realize this was just the product of part A and part B. All right, now part D. From your answer to part C, give the value of f triple prime 0, the third derivative at 0, where f of x is cosine x of 1 plus x. So if you've been following along in this series, I explained it in like problem 10 or 11, something like that. But let me explain it one more time. The quick way to do this, once you understand the concept, is we look for this is third derivative, right? We look for the third degree term, which is right here. We take the coefficient that's out in front of the x cubed, which is minus half, and we multiply it with 3 factorial. Okay, so the answer is minus 3, and you're done. Now let me explain one more time why we do that, okay? Since we have this expanded form, let's take the third derivative. If we take the first derivative, this 1 would go away, right? Then we have minus 1 plus x minus 3 over 2x squared, so on and so forth. Take the second derivative, that minus 1 would go away. Then we have, this was what? This is x, right? So it would just be 1 minus 3 over 2x. Oh, minus 3x, sorry. Minus 3. Okay? Yeah, minus 3x plus so on and so forth. Take the second derivative. Or that was second, right? Take the third derivative. See, I lost track already. That constant would from this term would go away. Then we're left with minus 3 here, which is right there, and then so on and so forth. So notice when we take the third derivative, anything that's lower than degree 3 would have gone away from the power rule already. Okay, that's number one. Number two, for any higher order terms, like x to the fourth, when we take three derivatives, there's still powers of x remaining. So like for the x to the fourth term, there'll still be one power of x left from the power rule. When you plug in the center, x is 0, the terms would all go away. Okay, so even notice, if we take 0 derivatives, this term would go away when x is 0, this term will go away, this term will go away, so on and so forth. It's similar for when we take the third derivative, any high order terms, high degree terms, whatever the term is, would go away when we plug in x is 0. And so that's why we're left with whatever initial constant was out in front of the x cubed, the third degree term, which is minus half. And then from the power rule, we keep bringing down the power, right? So we'll have a 3 factorial. So that's the quick way to do these. Hopefully, if you're following along, and I think this is the third time I explained this now in this series, because I'm filming all this in one day right now. This concept got solidified now at this point. Okay, so is that it for this question? I think so. Okay. Yeah, hopefully that was helpful. So this one, if you have the power series memorized for cosine, that would speed it up a lot. This one, you just start from the known one, and then it's not bad at all. This one, you just have to be careful of the algebra and realize that it's the product of the answer from A and B. And then this one I just explained, hopefully. All right. As usual, please give this video a like if this has helped you in any way. And hopefully see you in another video as well. Bye.